Hello students, welcome to Ncert Academy. Today we are going to learn class 10th Maths Chapter 1 Real Numbers Part 6 Solution of Ncert Textbook Exercise 1.2. Hello students, welcome to Ncert Academy. Now we are going to start with exercise 1.2 textbook exercise. So let us start with the first question. First question is express each number as a product of its prime factors. Okay friends. So it has 5 numbers given over here. So let us start with the first number. First number is what? 140. So what will be the prime factors of 140? 140 can be prime factorized as factor 3 of 140. 2 70s are 140. Then 2 35s are 70 and 5 7s are 35. Is it clear friends? So thus we can say that what are the prime factors of 140? 140 is equal to what? 2 raised to 2 into 5 into 7. Is it clear friends? There are two 2's, 2 raised to 2 into 5 into 7. So hope this is clear. Now we move to the second part. Second question. Second question is 156. So 156 can be prime factorized as 156. 2 7s are 14. 1 will be the remainder. 1 6 16. So 2 8s are 16. 2 78s are and 2 39s are 2 3s are 6. 1 will remain. 1 8 18 is 2 9s are 18. Then again 3 1s are 3. 3 3s are 9. So 3 13s are 9. So thus we can say that prime factors of 156 can be written as 2 square into 3 raised to 1 into 30. So these are the product of primes. Is it clear friends? So this is our second answer. Now we move to the third sum. In the third sum, this was the second. Now we move to the third sum. Third sum is what? 3825. So what can be the prime factors of this? It can be divided by 5. So 5 7s are 35, 3 will remain, 3 2 32, 5 6 are 30, 2 5 25, 5 5s are 25. Again it can be divided by 5, 5 1s are 5, 2 6 26 will remain, so 5 5s are 25, 1 5, 5 3s are 15. Again now 3 it can be divisible by 3. Why? Because the sum total of this will be 9. 1 plus 5 6 plus 3 is 9. So it will be divided by 3. So 3 5s are 15 and 3 1s are 3. Again it can be divided by 3. 3 1s are 3 and 7s are. So answer to this will be, what will be the product of primes of 3825? That is, if I write in an order form, 3 will come first. So 3 raised to, how many 3's are there? There are 2 3's, so 3 into square. There are 2 5's, so 5 square into 70. So this is my answer 3. Is it clear friends? Now we move to the next question, that is question number 4. That is 5005. So what are the prime factors of 5005? 5005 can be prime factorized by 5. 5 1001s are. Then 1001 can be prime factorized by 7. 7 1s are 7. 3 will remain. 3 0 30. So 7 4s are 28. 2 will remain, 2 1 21, so 7 3s are 21. Again 143, this can be divided by 11. 11 1s are 11, so 3 will remain, 3 3 33, so 11 3s are 33. So 11 into 13 is 143. So what are the product of primes of 5005, that is, which is the first one, 5 into 7 into 11 into 13. So these are the product of primes of what? 5005. Is it clear, friends? Now we move to the next question, that is the fifth one. So what will be the answer of this fifth one? 7429. What can be the prime factors of this 7429? It can be divided by, it cannot be divided by 3, it cannot be divided by 11 also. So let us say 7429 is divided by 17. So 17 threes are 21. It will be 51. And 17 fours are 68. So it will be 17 fours are 68. Okay. So 14 minus 8 will be 6. And 6 minus 6 will remain 0. So 62. So 17 threes are, it will be what? 51. So 1, 1 and 9. So 17 sevens are, 7 sevens are 49. 7 ones are 7 plus 4 is 11. So 7s are, it is 119. So it is 17 into 437. So 17 multiplied by 437 is 7429. Is it clear, friends? Now next number, it will be divisible by what? Let us see the next prime. 437 divided by 11. We cannot divide it. So let us take another number. 7 after 17 comes 19. 19 twos are 38. So 13 minus 8 is what? 5 0 7. 19 threes are 57. So it is the prime factor of 19 and 23. So 19 into 23. 23 is itself a prime factor. So here your answer will be what? Prime factors of 7429 is equal to 17 into 19 into 23. This is your final answer. So hope, friends, this is very easy. Product of primes, we have to just prime factorize it by making a factor tree, and we have to find the product of primes. So hope it is clear. Now we move to the next question, that is question 2. So friends, now we move to question second. What does question second says? Find the LCM and HCF of the following pairs of integers. We are given the two pairs of integers, and verify that LCM into HCF is the product of two numbers. See, friends, these we have already discussed in the HCF LCM concept. LCM of these two numbers into HCF of these two numbers will be equal to product of two numbers. This we have to verify. So let us start with the first sum. So first we have to find LCM and HCF of these two numbers, 26 and 91. Okay. So prime factorization of 26 is 2 13s are 26. And what is the prime factorization of 91? 13 7s are 91. So 26 can be written in the product of primes as 2 into 13, and 91 can be written as 7 into 13. So here, friends, what is my HCF? HCF of 26 and 91 is the common factor with the least power. So which is the common factor? 13, and there is only single power 1. So HCF is what? 13. And LCM of these two numbers is the common factor with the greatest power. So here there will be 13 only. Okay, and बाकी के जो सब uncommon factors बचे वो. So 13 into 2 into 7. So 13 into 2 into 7 is what? 13 into 14. So what is 13 into 14? 4 3s are 12. 4 1s are 4 plus 1 5 3 1. So it will be what? 182. So this is my LCM. Now friends, we have to verify. What we have to verify? That the LCM into HCF is product of two numbers. So let us multiply this first. HCF into LCM of these two numbers is what? 13 into 182. So 13 into 182. That we will get as 182 multiplied by 13. 3 2s are 6, 3 8s are 24, 3 1s are 3 plus 2 5. 2 8 1. So 6 6 5 plus 8 is 13. So it is what? 2366, 2366. Okay friends. Now we prove the RHS, that is what? Product of two numbers. So product of two numbers, which were the two numbers given over here, 26 and 91. So multiply this 26 into 91. 26 into 91 is what? 6 2. 9 6 are 54. 9 2s are 18 plus 5 is 23. So 6 6 2 3. So again we got the same answer, that is 2366 friends. So here with this what we did is, therefore it is verified HCF into LCM is equal to product of two numbers. Okay, or you can write it in the another way as HCF of these two numbers was 26 and 91 into LCM of these two numbers 26 and 91 is equal to 26 into 91. Hence it is verified. Is it clear friends? So it was very easy. पहले हमने HCF फाइंड किया, फिर LCM फाइंड किया, फिर हमने HCF और LCM को मल्टीप्लाई किया. उसका जो आंसर है वो ये दो नंबर के प्रोडक्ट से इक्वल आना चाहिए. So LHS is equal to RHS and hence it is verified. Now let us start with the second question. What does the second question says? The second sum is 510 and 92. Okay, so I am doing over here. What are the prime factors of 510? 5 1s are 5, 0 2s are, then 102 can be divided with 2, 2 5s are 10, 2 1s are 2, then 51 can be divided by 3, 3 17s are 51. Is it clear? No need to see the order of primes. Okay, कोई भी prime numbers ले सकते हैं. Now 92 can be divided with 2, 2 4s are 8, 1 2, 2 6s are 12, then 2 23s are 46. So these are the prime factors. 510 के prime factors कौन से हैं? 2, 3, 5 and 17. So 2 into 3 into 5 into 17. And these are the product of primes of 510. And 92 के product of primes कौन से हैं? 2 square है. 2 is repeated 2 times, 2 into 2 into 23. Okay. So here friends, while finding the HCF, HCF will be what? 510 and 92 का HCF क्या होगा? The common factor with least power. So least power is what? 2 raised to 1. So it is what? 2. And LCM of these two numbers will be what? 502 and 92 will be common factor with the greatest power. So it is 2 raised to 2. So 2 raised to 2 into बाकी सब uncommon factors. So 2 raised to 2 into 3 into 5 into 17 into 23. It will be a big multiplication friends. So it is what? 2 square is what? 4. 4 3s are 12. 12 5s are 60. So 60 into 17 into 23. So let us do this. 17 into 6 is what? If I have to multiply 17 into 60, let us multiply 17 into 6. 7 6 are 42. 6 1 are 6 plus 4 10. So it will be what? This will be 1020 into 23. So let us multiply this 1020 into 23. So 3 zeros are 0, 3 2s are 6, 3 zeros are 0, 0, 2 2s are 4, 0, 2. So 0, 6, 4, 3, 2. So answer will be what? 23460. That is 23,460. So I can directly write over here. If I multiply this all digits, it will be 23,460 will be my LCM. Now let us check and verify whether this is true or false. Now see friends, first of all HCF of these two numbers 510 and 92 into LCM of these two numbers 510 and 92 is equal to, दोनों को मल्टीप्लाई करो तो 2 into 23,460. Okay, so 23,460 into 2 is what? 2 6 are 12, 2 4 are 8 plus 1 9, 2 3 are 6, 2 2 are 4. So it is what? 46,920. Is it clear? Now I multiply the product of two numbers. So product of two numbers, that is these two numbers multiplied is 510 into 92. That what answer I will get? 510 into 92 is 2 zeros are 0, 2 ones are 2, 2 fives are 10, 9 zeros are 0, 9 ones are 9, 9 fives are 45. So 02964. So again I get what? 46,920. So hence friends it is verified. So therefore we can write hence HCF of 510,92 into LCM of 510,92 is equal to 510 into 92. So hence this is verified. Is it clear friends? So this way you have to verify it. You have to find first HCF, then you have to find LCM, then multiply the HCF with LCM, you will get some answer, and multiply the product of two numbers, you will get that answer, that LHS should be equal to RHS. This is the way we verify it. Now the last sum, that is the third sum of question 2. The third sum is 336 and 54. Okay friends, it is 54, 5, 4. So prime factors of 336 and 54. What will be the prime factors? 2 से divide होगा, 2 1s are 2, 1 3, 2 6 are 12, 1 6 2 8s are 16. Again 2 से होगा, 2 8s are and 2 4s are, again 2 से होगा, 2 42s are, again 2 से होगा, 2 21s are, then 3 7s. Is it clear friends? Now we move to the next one, that is prime factors of 54. 2 27s are 54, 3 9s are, and 3 3s are. So prime factors of 336 के प्राइम फैक्टर्स कितने हैं? 2 into 2 into 2 into 2, 4 times 2, so 2 raised to power 4 into 3 into 7. And what are the prime factors of 54? 54 is 2 one time and 3 are repeated thrice, so 3 raised to cube. So in this case HCF of 336, 54 will be the common factors with the lowest power. So 2 2 कॉमन है, लोएस्ट पावर क्या है 2 में, 4 के 1 1, so we write only 2. फिर ये दोनों भी कॉमन फैक्टर है, 3 3 is also common factor, which is the lowest power among this 3 and 1 1, so 3 raised to 1 is 3, so my HCF will be what? 6. Now coming to LCM of 336 and 54, ये दोनों का LCM लेंगे तो कॉमन फैक्टर विथ हाईएस्ट पावर, सो कॉमन फैक्टर 2 2 है, उसमें हाईएस्ट पावर कौन सा है 4, सो आई विल कीप 2 raised to 4. अगेन द कॉमन फैक्टर विथ हाईएस्ट पावर 3 है, 3 का कॉमन फैक्टर विथ हाईएस्ट पावर इज क्यूब इनटू अनकॉमन फैक्टर्स. नाउ अनकॉमन फैक्टर लेफ्ट इज व्हाट? 7, so into 7, so it will be 2 raised to 4 is 2 2s are 4 2s are 8 2s are 16 into 3 cube is 27 into 7, so 27 into 16 is what? 6 7s are 42, 6 2s are 12 plus 4 16, 7 2 2 13 and 4, so it is what? 432 multiplied by 7, so into 7 if I do, 7 2s are 14, 7 3s are 21 plus 1 22, 7 4s are 28, 28 plus 2 is 30, so you will get answer what? 3024. So hope this is clear friends. Now I am rubbing this. Now what I have to do is multiply the HCF of these two numbers 336 and 54 into LCM of these two numbers 336 and 54. So it is equal to what? It is equal to HCF is 6 into 3024. So what is 6 into 3024? Let us do. 4 6 are 24, 6 2s are 12 plus 2 is 14, 6 zeros are 0 plus 1 is 1, 6 3s are 18. So answer is what? 18144, that is 18,144. Now product of two numbers. Okay, so product of two numbers, that is, which were the two numbers? 336 into 54. So let us do this. 336 into 54, 4 6 are 24, 4 3s are 12 plus 2 14, 4 3s are 12 plus 1 13, 5 6 are 30, 5 3s are 15 plus 3 18, 5 3s are 15 plus 1 is 16. So 4 4, 8 plus 3 11, 8 and 1. So it matches with our previous answer 18144. So LHS is equal to RHS. So hence we can write as, therefore HCF of 336, 54 into LCM of 336, 54 equals to 336 into 54. So hence it is verified. Is it clear, friends? It was very simple part. Now we move to the next question, question 3 of this exercise. Now friends, let us start with question number 3 of this exercise. What does the question number 3 says? It says find the HCF and LCM of the following integers by applying the prime factorization method. Now you are very familiar with the prime factorization method. Yes. So first one we are doing it. There are three integers given over here. 12. What will be the prime factors of 12? 2 6 are and 2 3s are. Then 15. What will be the prime factors of 15? 3 5s are 15. And 21, what will be the prime factors of 21? 3 7s are 21. Is it clear? So 12 is written as 2 into 2 into 3, that is 2 square into 3. Okay, 15 is written as what? 3 into 5. And 21 is written as what? 3 into 7. Now see friends, I have written in this way so that you get a clear cut idea what is common factor over here among all the three. So HCF of 12, 15 and 21 is what? The common factor with the least power. So all have power 1 1 1. So HCF will be what? 1 1. 3 raised to 1 is 3. Now LCM. LCM of these three numbers will be, first take the common factor with the highest power. So that will be also the same number, that is 3 raised to 1. Highest भी 1 है और lowest भी 1 है common factor में. So 3 raised to 1 into uncommon factors. So what are uncommon factors left is 2 raised to square into 5 into 7. So 3 into 2 square is 4 into 5 into 7. 3 4s are 12, 12 5s are 60, 67s are 6 7s are 42. So what is the LCM of these three numbers? 420. Is it clear friends? बहुत इजी है. सबसे पहले मैंने कॉमन फैक्टर विथ हाईएस्ट पावर लिया, फिर I multiplied the uncommon remaining factors, that is 2 raised to 2, 5 and 7, वो सब multiply कर लें. Is it clear? Then moving to the next question, that is sum number 2 of question number 3. Okay. Now let us solve these three numbers. So 17 का prime factors क्या होगा? Solution of answer 2. 17 के prime factors 17 ही रहेगा. 17 1s are 17, so no need to prime factorize it. 23 is also prime number and 29 is also prime number. So these all three are having 1 as a common factor. So they are called as co-primes. So prime factor of 17 is 17 into 1, 23 का prime factor 23 into 1 and 29 का prime factor 29 into 1. So in all these three are prime factors. So HCF will be 1. HCF of 17, 23 and 29 as they are co-primes. So HCF will be 1 and LCM of these three numbers will be the multiplication of all these numbers. Remember the point or concept that we discussed in HCF and LCM, the third point. Okay, so when they are co-primes, HCF will be 1 and the LCM will be the product of the numbers. So we will multiply all these numbers. Okay, so 23 into 17 is what? 7 3s are 21, 7 2s are 14 plus 2 16, 3 2, so 1 9 3, then 391 multiplied by 29, so 9 1s are 9, 9 9s are 81, 9 3s are 27 and 8 35, then 2 1s are 2, 2 9s are 18, 2 3s are 6 plus 1 7, so 9 3, 8 plus 5 is 13, 10 plus 1 is 11, so it will be 11339, 11,339. So hope this is clear, friends. It was very easy. HCF we got as 1 and LCM we got as 11,339. Okay, now we move to the third sum of this question, that is this one. So let us solve that third one. Prime factors of 8 is 2 cube, that is 2 4s are 8, then 2 2s are. Then prime factors of 9 we know, 3 3s are 9 and 25 के prime factors क्या होंगे, 5 5s are 25. So 8 can be written as 2 cube, 9 can be written as 3 square and 25 can be written as 5 square. So again here, friends, there is nothing common. Okay, so what we can write as all these have common as 1. Okay, so HCF of these three numbers 8, 9 and 25, these are not prime numbers but these are all three composite numbers and they are having 1 as a common, so it is 1. And LCM of these three numbers 8, 9 and 25 will be multiplication of all these numbers. Is it clear? Why? Because there is nothing common. So highest power 2 में क्या है? 2 raised to cube. 3 में highest power 3 raised to square and 5 में highest power. So multiply this all with highest power. So 2 cube into 3 square into 5 square. So it is 8 into 9 into 25. Okay, 8 9s are 72. 72 into 25, 5 2s are 10, 5 7s are 35 plus 1 36, 2 2s are 4, 2 7s are 14. So 0, 10, 4 plus 4 is 8. So it will be what? 1800. So this is your answer. Is it clear, friends? So it is very easy. Question 3 was a very easiest question. Just we had to find the HCF and LCM by the prime factorization method. Now we'll move to the next question, question number 4. So friends, what does question 4 says? Given that HCF of these two numbers 306 and 657 is 9, find LCM of these two numbers. So we will be using that concept. Remember the concept? HCF of A comma B into LCM of A comma B is equal to product of two numbers, that is A into B. This concept. Okay, so यही concept हमें यहाँ apply करना है. What will be A over here? A will be 306. What will be my B? B is 657. So instead of this I can write it as HCF of 306, 657 into LCM of 306, 657 equals to 306 into 657, that is A into B. Okay, so HCF हमें दे दिया है, ये सब के जगह I can substitute instead of HCF what I can write 9. LCM we have to find, so we'll write as it is LCM of 306 and 657 equals to 306 into 657. Now this 9 is multiplied, I will take to this side, then it will get divided. So it will be what? LCM of 306, 657 equals to 306 into 657 divided by 9. So I can divide this by 9. 3 plus 6 is 9. So it is divisible directly by 9. 9 3s are 27. 3 6 9 4s are 36. So it will be 34 into 657. So let us multiply this. 657 into 34. 4 7s are 28. 4 5s are 20 plus 2 22. 4 6s are 24. 24 plus 2 26. 3 7s are 21. 3 5s are 15 plus 2 17. 3 6 are 18 plus 1 19. So 8 3 6 plus 7 13. 9 10 and 2 12 and 2. So answer will be what? 22,338. This is your LCM. Is it clear, friends? So we use that relationship between HCF, LCM and two numbers. Okay? So it is very easy to understand. Just we substituted the value of HCF. Instead of HCF we kept as 9, and then we took this 9 to the next side. It got divided with these two numbers. So these two numbers divided by 9, we got answer what? 34 into 657 is what? 22,338. Okay, friends. Now we move to next question 5. So friends, now what does question 5 says? Check whether 6 raised to n can end with a digit 0 for any natural number n. This type of sum we have already done in the illustrations part. Okay, friends. So it is very easy to check it. Again I am explaining 6 raised to n. See, 6 raised to 1 is what? 6. 6 raised to square is what? 6 6 are 36. 6 cube is what? 6 into 6 into 6 is 616. Okay. So यहाँ पे last digit सब में क्या आ रहा है? What is the last digit in each case? 6. So from this only we can know that there cannot be any last digit 0 in this case. So but we have to show it. So how we will show it? So first what we will say is, if a number ends with a digit 0, if a number ends with a digit 0, it would be divisible by both numbers 2 and 5. Okay, in the previous sum it was 4 raised to n, so there was 2 in that case, so but there was not 5 in that case. Here also these two numbers should be represented in the prime factorization of that number. Is it clear? So hence the number ending with 0 must have 2 and 5. Hence the number ending with unit digit 0 must have 2 and 5 in it as a prime factors. Okay, so here first point what we wrote is, if a number ends with a digit 0, it would be divisible by 2 and 5. So another thing is what? That means what? 2 and 5 should be there in their prime factors. Okay, so now if we prime factorize this 6 raised to n, it will be what? 2 into 3 whole raised to n. Prime factors of 6 is what? 2 into 3 whole raised to n. Is it clear? So we can write as 2 raised to n into 3 raised to n for any natural number n. Is it clear? So in this case, prime factorization, we have only 2 factors. So thus in 6 raised to n we have only 2 two prime factors, that is 2 and 3. Is it clear? दो ही prime factors है 2 and 3. So the prime factorization of 6 raised to n, the prime factorization of 6 raised to n does not include 5 as a prime factor. Okay, तो इसके prime factorization में 5 is not included in a prime factor, and hence we can say that 6 raised to n cannot end with the digit 0 for any natural number n. Is it clear? बहुत सिंपल सा केस है. इसको प्रूव करने के लिए ये 4-5 पॉइंट्स जो है वो आपको याद रखनी है. पहली पॉइंट है कि यदि इफ अ नंबर एंड्स विथ अ डिजिट 0 तो उसके डिविजिबिलिटी में कौन से नंबर्स प्राइम फैक्टर्स होने चाहिए? 2 and 5 दोनों से डिविजिबल होने चाहिए, दैट इज 10 से डिविजिबल होने चाहिए, तो ही लास्ट 0 आएगा. सेकंड, hence the number ending with 0 must have 2 and 5 in its as a prime factors. तो इसका ही कंसेप्ट यदि दूसरी तरह से देखा जाए तो we can say that उसके prime factors में there should be 2 and 5 as a prime factors. Is it clear? So now 6 raised to n के prime factors करें तो it will be 2 into 3 whole raised to n, that is 2 raised to n into 3 raised to n for any natural number n. N can be any natural number, right? Then thus in 6 raised to n we have only two prime factors, that is 2 and 3. यहाँ पे दो ही prime factors है 2 और 3. हमें चाहिए थे कौन से? 2 and 5. तो 2 तो है, but there must be one 5 in that case. But here we are not having 5. So the prime factorization of 6 raised to n does not include 5 as a prime factor, and hence 6 raised to n cannot end with the digit 0 for any natural number n. Is it clear, friends? So hope this is clear. It is easy to understand. Now we move to the next question. Question 6. So friends, what does question 6 says? Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Okay? So we have to explain कि ये दोनों को क्यों composite numbers कहा जाता है. Let us start with the first. 7 into 11 into 13 plus 13. Okay, so this is my one term and this is my another term. दोनों term में there is common 13 in both the terms. So if I take out 13 as common, what will left inside? 7 into 11 is what? 77 plus here 13 into 1 is 13. So inside it will be what? 1 will be left. So it is what? 13 into 78. Is it clear? So if I represent 78 as a prime factor, 3 2s are 6, 1 8, 3 6 are 18, then 2 13s are and 13 1s are. So prime factors of 78 is what? 3 into 2 into 13. So I can write 13 into 3 into 2 into 13. So it is written as 13 square into, or in the form of order form we can write 2 into 3 into 13 square. Is it clear? So this whole term is expressed as a product of primes. So therefore, as it is expressed as product of primes, therefore it is a composite number. Okay, so this is a composite number. Why? Because it can be expressed in the product of primes. Similarly, the another one, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So this is one whole term and this is another term. Okay, so in this case what is common in both this term? 5. So if I take out 5, I can write it as 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay, so it will be what? it will be 5 into 7 6 are 42, 42 into 3 2s are 6, 6 4s are 24. So what is 42 into 24? 4 2s are 8, 4 4s are 16, 2 2s are 4 and 2 4s are 8. So answer will be 1008 plus 1. This whole, if I multiply, I'll get 1008 and plus what will remain here. 5 is also multiplied with 1. So if I take out 5 as a common, what will be left inside the bracket? 1. So it is 5 into 1009. Is it clear? So 5 into 1009. 1009, it is also a prime number. So we can write as 5 into 1009. So these also we expressed as a product of primes. Okay. So here also, here I represented as a product of primes and here also I represented as product of primes. So the same statement we have to write in answer, that as it is expressed, both these numbers are expressed as a product of primes. Therefore, they are a composite number. Okay, I am changing this statement. Instead of it, as they are expressed as product of primes, therefore they are composite numbers. Is it clear, friends? So it was very easy. How we can prove that it is a composite number? जब कोई भी number को हम product of primes में represent कर सकते हैं, then it is said as composite number. So hope this is clear, friends. Now we move to the next question, that is question number 7. So here, this is the last question of this exercise, friends. It is a problem sum. So what does this say? There is a circular path around the sports field and Sonia takes 18 minutes to drive one round of the field. Okay, so say this is a sports field. Okay, and there is a circular path like this way. Okay, so there is a circular path around the sport field and what is given that Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. तो उसका मतलब क्या कि सोनिया takes more time than Ravi. Okay, उसको सोनिया को वन राउंड कंप्लीट करने में 18 मिनट्स लगती है एंड रवि को एक राउंड कंप्लीट करने में 12 मिनट्स लगती है. सपोज दे बोथ स्टार्ट एट द सेम पॉइंट एंड एट द सेम टाइम एंड गो इन द सेम डायरेक्शन. ठीक है, मान लेते हैं, लेट अस अज्यूम दैट दिस इज द स्टार्टिंग पॉइंट. ओके, दिस इज सोनिया एंड दिस इज रवि. ओके, सो इफ दे स्टार्ट विद द सेम स्टार्टिंग पॉइंट, ठीक है, सेम पॉइंट से शुरू करते हैं सेम टाइम पे एंड इन द सेम डायरेक्शन, दैट मीन्स दे आर मूविंग टुवर्ड्स दिस क्लॉकवाइज डायरेक्शन. मान लेते सपोज, देन आफ्टर हाउ मेनी मिनट्स विल दे मीट अगेन एट द स्टार्टिंग पॉइंट. सो इफ दे कंटिन्यू दिस, एट द एंड ऑफ वन राउंड सोनिया विल बी बिहाइंड 6 मिनट्स देन रवि. ठीक है, एक राउंड कंप्लीट होगा तो रवि की 12 मिनट्स में वन राउंड कंप्लीट होता है. Sonia will take 18 minutes. That means Sonia will be behind Ravi 6 minutes at the end of one round. Is it clear? So ऐसे second round में how many minutes का difference रहेगा? That will be 12 minutes difference. So here what you have to find is, and then it will be continued. So here you are asked to find after how many minutes they will meet again at the starting point. So वो दोनों यहाँ पे starting point में ही इकट्ठे होने चाहिए. So friends, it is very easy trick. Whenever this type of sums comes, that they both starts at the same point, then at the same time, and they go in the same direction. Okay, and when they will meet at the starting point again, so it is simple solution. Just you have to find the LCM of these two numbers, 18 and 12. Okay, so if we find the LCM of these two numbers, LCM of 18 and 12, is it clear? So if we find this, 18 factor is what? 2 9s are 18 and 3 3s are 9. What are the prime factors of 12? 2 6 are 12, 2 3s are 6. So 18 can be written in the forms of product of primes as 2 into 3 square, and 12 can be written as 2 square into 3. Okay, so LCM of these two, 18 and 12, will be, these are the both are common factors, so common factor with the highest power in case of LCM. So highest power in this is what? 2 raised to 2, and in this case of 3 as a common factor, what is the highest power? 3 raised to 2. So it is 4 into 2 square is 4, 3 square is 9. So 4 into 9 is what? 36. So LCM is 36 minutes. So in the last answer, what I can write as, after how many minutes they will meet again? So we can write that after 36 minutes, comma, they both will meet again at the starting point. Okay, so whenever this type of question comes and these type of words are used, you have to keep it, remember, you have to just remember, you have to find the LCM and find the answers. So students, with this we complete today's session. Thank you very much.
Thank you students for watching this video. To view our more videos, please click on like and subscribe button given below. Thank you.